This is Math 221B. We are starting to broadcast a little late, but you can follow up pretty quick. We are looking at our project for final project, talking about the idea of what we're going to do with gas station prices in Boise.
Okay, so for number 9, I'm just going off of the example here that he has. So 1, we will list zip codes. Zero people in a random order. We will switch zip. If anyone wants to correct me on anything I'm saying, just go ahead.
All right, that's cool. They look fine right now.
Right, whether there are 9.
Yeah.
No, I don't want to go there. I want to go there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9.
You doing okay, Camden?
Yep.
So 3, I will pick every 3rd town after that. Okay.
So what did we decide on how we want to sample? Is it going to be clusters? So every
enter each of the into will take prices from each within Okay, does that sound good? I mean, does that sound like it's
Yes, add one more talking about what we're going to do with ANOVA. Say we will use an ANOVA chart to compare the mean samples of stuff or something like that. That makes sense.
Well, this is just collecting the data, I think.
All right, yeah, no, you don't have to do if you don't want to.
Yeah, collect data. So I think we're good.
Yeah, no, that sounds reasonable.
Okay, so number 10, please review the requirements.
I think we're set on 10. So this is pretty much it. You go straight to 19 after this, and just needs to be approved. So
yeah.
Okay, we just need to sign.
Yeah, that's what I'm thinking. So if you want, turn it in today.
Awesome.
That's fancy, Camden.
Sorry, Camden.
Hopefully we don't have very many revisions.
Yeah. I can't imagine it would be we may need 1 or 2 in terms of like how we write it, but I can't imagine there's any problem with the project itself.
Yeah. Perfect. Well, that was simple. Now we can move on.
Our group quiz.
Are we supposed to keep writing something about 10? Oh, it just says to review them and discuss.
All right.
That's just me verbally out loud with each other, and we already did that. So All right.
Camden, you okay turning this in?
Yeah, I can turn this in.
No, not Camden. Sorry, Davis. Sorry.
Yeah. I'll turn it in today even.
Yeah. So all you have to do is go to File, download it, make sure the download's good, and then you can turn it in from there.
Got it. Yep, I'll do that after I go home from work tonight.
All right. One sec. Hello? I hate spam calls.
Oh man, I get them every day.
I get them all the time, dude.
I get a lot of political spam right now because elections are going on, and I'm in a really hot demographic zone in terms of the race, and so I'm getting like every day at least one or two is political asking, "Are you gonna vote for him?" You know.
Yeah, it's funny because I call people every day, so like at work, and so and I hate it when I get calls, and it's funny.
You're in sales, right?
Yeah. But like with mine, it's like it's not random. Like the people enter their information into our website, whether they know it or not. They do it.
Yeah.
So,
well, it's like my sister works for AAA, and she calls her members and asks if they need help. And more importantly, members call her and ask for help.
Yeah.
Anyway,
all right.
Let's start this quiz.
Yeah.
You ready?
Yep.
Well, I'm not yet. Sorry.
Is it the first one, question 3? Is that C, this regular P?
Yes.
Yep.
I feel like that's kind of a trick question.
Mm-hmm.
All right. For the next 2 questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10 or 0.1. Requirements for constructing a confidence interval are satisfied.
True.
Do we need to test this real quick?
Yeah. So it's n times p, and then what was the second one again?
No, actually, n times p hat. That's one of the things.
Oh.
Let me pull it up.
I have it right here. Just
Okay. I believe.
There we go. What the freak?
Everything all right?
Yeah, I'm just trying to find it here. Oh yeah, sorry. Yeah, it's p hat.
All right. So,
and it's n times 1 minus p hat.
Yeah.
And then n times p hat.
So n times p hat I already know is going to be okay.
Yeah.
Because 0.1 times 100 is 10. Let's try. Yep, that's good. It's between 1 and 90, so that's fine.
Okay, so true.
Yep.
What is the requirement for that?
So 1 is n times p hat, so 100 times 0.1, which is 10. It has to be higher than 10. So it can be equal to or higher than 10. And the second one is n times 1 minus p hat is equal to or higher than 10.
Mm-hmm.
Okay.
So basically, it's the real thing is in 1 minus p hat is going to be bigger than 1 times p hat. So as always p hat times n is good, most of the time it'll be okay.
Yep.
Okay.
All right. 5 then.
Mm-hmm.
That's true, correct?
It's yeah.
All right. I'll read the next section. A study of first-degree murder trials was conducted in our state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 defendants were found guilty. Find P hat the point estimate the proportion of first-degree murder defendants who are found guilty in the state. So I was reading about this. I had a problem with my homework. It's actually like twofold. It's X, which is X is the population over the number. So X is 45 divided by 60, and then you divide it again by 60. That makes sense?
Why would you divide it again by 60?
Because X is 45 over X is the sample you're looking at over N, and you also divide it again by N. So it's X over N. X is not simply just 45. X is 45 over 60.
So that's weird because in the example on the reading, it says out of this group, so another study on honesty at medical school.
Yeah.
Out of this group, X equals 114 admitted to cheating in medical school, and you divided that by the ones that participated in the survey of 2,426. And to find P hat, all you did was divided 114 by 2,426.
All right. I'm not sure because I was confused by the video. The video was telling me that X is, and you have to do it twice. So, did you watch the first video?
No, I didn't watch it.
All right, that's where I was confused because the way they pronounced it was kind of weird. Let's go 45. Oh, okay, here's the deal. 45 over 60 is 0.75. It's asking for 3 decimals, and divided by 60 again is 0.0125. I'm not sure. Does someone else want to jump in here and give an answer?
Well, that's what I'm getting too. And looking just at the formulas, it makes sense.
Whoa, which one are you getting?
I'm getting 0.0125.
Okay. Sweet. Let's go with that then.
All right.
So it would be, so just for future reference, it would be then 45, let's say like just for this one, 45 divided by 60 and then divided by 60 again. So if you had another one, say the numbers were different, you would just divide the number that were guilty divided by the number that went on trial and then divided by that number again.
Yeah. So the way described in the video was X is not simply the number surveyed. It's number surveyed over the total number and then divided by the total number again.
Okay.
It's a little confusing. Again, if we get it wrong, then we'll try something else. I was not sure from the video, but that's what I was getting. So
gotcha. That makes sense because I think from the example, it was giving us X, which was probably, the number divided by.
Yeah.
Yeah. So, okay. Makes sense.
Someone want to read the next information section?
Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. In this state, there the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound.
You can just work on this. So 95, is that 0.195 or 1.95?
I'm looking it up now.
That one, I just need to memorize that.
1.96.
96, okay.
Well, you can do almost all of this on the
Apple.
On Excel.
Okay, that's right.
Just remember for X, it's 45 divided by 60, not 45. Wait, no, it's not. Does someone want to do it by hand just to make sure we're
Yeah, you want to do that, Camden? And I can do it too if you want to have two people do it.
Yeah, I'm looking something up in the textbook right now.
All right, I'll do it. What are you getting, Davis, on the computer?
For the lower bound or for the margin of error?
Margin of error.
Well, margin of error you do by hand, but the confidence interval, the lower bound and upper bound, you do. And I got those. I haven't done the margin of error yet.
All right, what are your confidence intervals?
Let's see here. 0.640 and 0.860.
All right, that's what I'm getting on computer too. Camden, when you're done, can you look it up on hand and make sure we're getting the same thing?
Yeah.
What are you looking up book-wise anyway?
I just need to look at this formula because I didn't have it in my notes.
Yeah, it's similar, but there's just enough difference and confuse people.
Right.
If I can pull it up here for you.
What'd you get for the margin of error, Brooks?
I'm working on it right now. I'm trying to do it by hand. So I'm pulling up the formula.
Okay. I just did it by hand, and I don't know if I'm right, but.
In this case, would P be what is P? Is it 45?
I thought it was 60.
P?
Yeah.
P is 45 over 60.
Okay, that's
P is the probability, the ratio.
All right, that's what I think it's going to be. All right, what are you getting, Davis?
For the margin of error, I got 0.612.
All right, I'm getting 0.1095. I think I'm doing something wrong.
Maybe I did something wrong too.
I'm going to try it one more time.
Whoa.
Yeah, I'm getting the same thing.
I'm getting 0.109.
Yeah, that's what I'm getting.
Okay. So I probably just did it wrong. How'd you do it? How'd you enter it in?
Me?
Yeah.
I did 1.96 parenthesis, square root, double parenthesis, 0.7.
Wait. 1.96. Because isn't the margin of error just 2?
It's the z critical times the square root of p1 minus p over n.
That's why. I wrote Z in my notes, but I thought it was a 2 when I was redoing it. Okay. No. Yeah. So I did it right.
So, Davis, tell me again. P is.
So
what is it? It's
P should be the actual proportion. So it should
Okay.
be
0.75.
Yeah.
So 45 over 60 is 0.75. That's what I'm putting in my number, just 0.75. What did you get, Camden?
Wait.
0.10956.
That's what I'm getting. Is that okay with you, Davis, Spencer?
Uh huh.
All right, that's. What are you, 110?
0.110. Yeah.
Actually, do 0.109. Last on my homework quiz, I had a number which was like 0.099, and I kept it as that, and I got it right. So I'm gonna put 109.
Maybe I'm wrong. Hold on, because I think that's P hat is.
Yeah. Okay.
But so what's P then?
Oh, 60 is an N.
Wait, what?
Well, I'm saying out of the numbers we got 60 and 45. 60 we know is N. So I'm thinking 45 is P, proportion of it. P hat, isn't P hat 0.013 though?
Yeah, that's
I'm gonna
true.
look in the book.
Well, see, I'm looking in the book and I can't find it.
Would it be in the last chapter? I just realized that you can access all the chapters using that same wiki page. That is really, really convenient. I didn't know that, and that's.
You learned from me?
No, I actually just did it. Yeah.
I always do that. It's so much easier. All right.
I feel like we're just doing something the hard way again. You know what I'm saying?
I feel like that
we
too.
always do that.
I know. We overthink it. And
I think we all just like are so intent on like thinking stuff through that we don't realize it's like right in front of us.
I think P is 45.
Yeah, I'm thinking. But is it okay? Yeah.
And honestly, I think we're wrong. I don't know why, but see, like, go to the book, and if you go down to where it's doing the PTC test, the people that can taste PTC.
Okay, let me find it. Is that 16 or 17?
Keep going. Go up. Go up. Go up. Oh, it's in the. Sorry, it's in the most recent one.
Okay, yeah, that's what I was asking.
Sorry, yeah,
No, that's cool.
So keep going down. It's like down towards the bottom.
Yeah, I'm doing that. Example.
Okay,
Here it is. Can you taste it?
So out of 118 people who participated in the research, 89 indicated they could taste PTC. So the proportion of people in the sample who could taste PTC is P hat equals 89 over 118. You see my confusion? Because they just
I would agree. Let's make our. This is where I'm confused, and mostly by the quiz itself. The quiz is giving this a decimal place for. So P hat. Okay, yeah, I agree. P hat is probably 45 over 60 then. That fine with you guys?
So 0.750.
Yeah.
If it's wrong, then it's probably the other way. But it's just like from the examples, like that's all it's doing, and so that's where I'm confused.
Well, the real question is on margin of error, is it still using 0.75 or is it using something else for P?
For P, I'm sure it's 45. But
well, because the weird thing is, I thought margin of error was supposed to be a decimal. If we use 45, it becomes really big.
True.
Well, here's the question. They also mentioned occasionally that P and P hat can be the same. So they mentioned we were looking for. So I don't know if that's right or not, but
Okay, it is significantly different from the assumed value of point. I'm looking at this example here, and so it says the assumed value is 0.7. So 70% of people can taste PTC.
Yeah.
Well,
they're not giving us an assumed value though.
So what do we just assume then, that it's 45 over 60?
I'm guessing because they don't give us that, so I guess we have to assume that's the case.
Oh, well, then let's do that, and if it's wrong, it's wrong. What was that number again?
45 over 60?
No, the number for the margin of error.
0.109.
109.
Okay. 0.110 because you round with the 5.
I'm not going to round it because I've noticed on several homework quizzes I got it wrong when I rounded it and it had like a 9 or something. But when I put it out as a full number without rounding, it was right. So I'm going to, if we get it wrong, it's my fault. We'll try something else. But like on the homework quiz, I had last one for 16. I answered as 0.099 and I kept it as that and I got it right. I feel like if you round too much, then it completely loses the aspect.
Yeah.
There was once on a homework quiz where, or maybe it was on the test. Yeah, it was on a homework quiz, and I was just copying the p-value from the Excel onto the answer, and I totally forgot to round it. So it was like point and then like 8 numbers or 9 numbers. And I got it right.
Really?
Yeah.
Well,
do we need to add another decimal to that?
I don't think so, but.
Okay, well, we can move on, and if we get it wrong, we can figure it out. But
all right.
So for the lower and upper bound, you could just get that from Excel, and that's 0.64, and then 0.640 and 0.860 is what I got.
Well, couldn't you also do it like 0.75 minus and plus that?
0.75 plus and minus. Well, you can do it. Yeah, you can do this whole equation out. But yeah.
I'm just checking it. That's all. Yeah, so I'm getting 641, and so for lower bound 0.641, and for the upper bound 0.859.
Okay, so the lower bound, I don't know what because it's 0.640 in Excel. I would go with that. There's probably just a rounding error somewhere.
All right. Okay. All I'm doing is using the 0.75, which is our p-value, and adding in 0.109. But it probably I can find with that.
But your upper bound is correct. Because 0.859 would be 0.860, which is what they have in the Excel. Yeah. So that's what I'm saying. There might just be a rounding error in the other one.
All right. I'm gonna do as 0.641 and 0.859, and if I get it right, great. If I get it wrong, I know I just need to change that to a 0.
Okay.
All right. Question 10. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
Decrease.
Decrease, yeah.
Yeah, that's what you're saying. To conduct a hypothesis test for one proportion, 2 requirements must be met. The post p equals 1/2. What is the smallest n that can be, and both requirements still be met?
30.
Okay, so you have this equation here. So it's n equals. Let me make sure.
I think it's because basically when I set it up, I set up a hand. So n 1 over 2 equals 10 over 1, and it's cross multiply.
What was that?
Well,
so there's the n. They give you the equation. So it's n equals z over m squared times p times 1 minus p.
Aren't we looking for hypothesis tests though? Are we? Yeah, I meant that.
So we're looking for n. What is the smallest n can be, and both requirements still be met.
Yeah, but aren't we doing the condition test in P equal to minus 10?
Oh, yes. Sorry. Yeah, that's what we're doing. You're right.
So I would think it'd be 20 because this 1/2. All you have to do when you have to find half number of 10 is times 10 by 2.
Yeah, you're right. 10, 20. You're right.
You okay, Davis?
Yeah, I'm good. It's been a long day.
Yeah, it's cool. So the next one would probably be 100 because it's 10 times 10. You understand how I'm getting that? I'm just cross multiplying.
Yeah.
All right.
I didn't understand it until you said it, so thank you for knowing that.
Yeah. When you're doing proportions and you got like a number times a proportion, and you're trying and equal to a solid number, cross multiplying gets rid of it really fast.
Makes sense.
Okay, I'll read the next section. For the water quality supply in the reading, about 60% of macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality area has decreased. The conducted hypothesis testing significant level alpha equals 0.05. The hypothesis test P equals 0.6 and P is less than 0.6 for the alternative. They collect new data, this time N equals 80, X equals 38, and they get good health. So 13, the conditions for conducting a hypothesis are satisfied.
I believe so.
All right, well, this question would just be, if P equals 0.6, let's just double check to make sure 0.6 times N is, oh.
Yeah, it's 48.
Yeah. All right, we're good then. So I'm going with 13.
What's the requirement there that you guys are looking for?
All right, we're looking for the P, the null hypothesis, the P. We're making sure that is between that and the N for a sample size are enough. So 0.6 times 80 is going to give us a number bigger than 10. That's
Okay,
what
so
we're
as long
on
as
about.
it's bigger than 10, then it's good.
Yeah. So
Yeah.
like what our last question, we're talking about the smallest N we can have to be, if P is 1/2, smallest N is 20. That's because if your P 1/2 times 20, then you're going to get a 10. And basically that's sort of like their central limit theorem with proportions.
Okay. Okay.
That's kind of how they describe it. So what is P hat?
475.
Well, isn't P hat 0.6 repeating?
No, P hat would be X over N.
Yeah. So 38 over 80.
Mm-hmm.
Okay. Yeah. I'm not sure why.
I was like, that's what I'm getting.
I'm just getting super confused. I think I'm overthinking everything.
We always do that.
I know.
There's a test statistic 0.6 then?
The test statistic, what is the test statistic again for this?
I always forget this. Give me 1 sec. I'm going to look at a textbook. All right. Is the test statistic and point estimate the same thing?
No.
I don't think so.
All right, yeah. That's...
Oh, the test statistic would just be the null hypothesis. Or
Yeah.
The mean, right?
Yeah, so isn't it 0.6 then?
But it's not the population mean, it's the sample mean.
So it's 0.475 then? I'm thinking it's the population mean, so 0.6, but I could be wrong. I'm open to answers on that.
Maybe it is.
I'm gonna see if I can find it in here.
There's a formula in the book that has the explanation of the test statistic. If you go right above the applet, it has an equation.
Oh, we are so wrong. Test statistic is the z-score.
Yeah, I just looked it up. It's the z-score.
We are really out of it today.
Dude, what's wrong with us? I don't understand.
Sure.
All right, thank you, Spencer. Thanks,
Spencer. Seriously.
All right, so everyone want to take a chance to look at that real quick.
It's the value minus the mean over the standard deviation.
Yep. So I'm gonna compute it on hand and then get us saying what you do it the same, so we can check those.
And remember, so P is going to be 0.6, right?
Yes.
Okay.
P hat is our 0.475. So I believe it's going to be a negative z-score.
Okay. Yes.
All right. I got negative 2.282. I'll wait for you guys to get back to it. Let me see.
You're pretty quick there, dude.
I have been doing I spent all of high school doing calculations, so I'm kind of good.
Okay, so you did explain to me how you did this.
All right, I did we got for our p hat 0.475, correct?
0.475, yes.
So I subtracted. I did 0.475 minus the p value, which is 0.6.
Okay.
And that's negative 0.1325, and that's all in one equation. That you answer, which is simply just I think it's answer is, I believe, on you can find on your calculator. Answer divided by square root of in parentheses 0.6 in parentheses 1 minus 0.6 in parentheses divided by 80, which is a number. So basically, I just broke the formula up into two sections. On the top formula, I did value minus mean, and then I took that answer and divided by standard deviation.
So you did parentheses 0.6 end parentheses?
No, so square root, parentheses, 0.6, open parentheses, 1 minus 0.6 in parentheses, divided by 80 double in parentheses. It's kind of confusing.
Yeah, seriously.
Well, in the parentheses, if you do it wrong, you just get an error, so you know something's wrong.
I'm getting negative 2.282.
That's what I'm getting.
What's n divided by 80? Negative 2.282.
All right. Yeah, the key to doing calculus and anything like that is learning how to do parentheses, because it's going to be some of those stuff you can't do by hand, and the parentheses, if you get that wrong, it's going to kill you.
Yeah, and I'm not good at entering things into calculators.
I had a good pre-calc teacher in high school who really helped me with that.
I have to retake pre-calc because I haven't taken it since high school, so I'm gonna retake it next.
I'm in the same boat, man. I'm
nervous.
I'm taking 101 right now just before I do pre-calc, and it's coming back pretty easily, so I'm sure it will for you too.
See, I'm not sure whether I want to take calculus as part of my higher level math or take quantitative methods.
Yeah.
I'm probably going to have to take calculus. It looks better on this resume or your stuff.
Mm-hmm.
Sorry, what was the answer to 15?
I'm getting it right now. I just need to figure out if it's higher or lower. 15 is 0.6. Sorry, that was your question, right?
Wait, no. 15 point negative 2.282, right?
Yeah, sorry. Yeah, we changed it. Never mind. I didn't change it. So
to find the p-value, we just need to put this all into the Excel, right?
Yeah, that's what I'm checking right now for the p-value, whether what we're looking at. The hypothesis is p is less than 0.6, which here's where I'm confused, because if we do less than, it's like 0.0112.
Hold on. Let me figure this out here. 80. Okay, we're doing 95% confidence interval. Our null hypothesis is 0.6.
I'm sorry, 0.6.
0.6, and the p-value is a less than, so make sure you get less than.
0.6. And less than. Yeah, so 0.011.
That's what I'm getting.
Okay.
I think that's right then. Which is kind of satisfying that we actually did it right by hand.
Yeah.
So the decision for this test then, we say reject.
Reject it all. I don't know why, but I've struggled through this thing today, man. Holy cow!
I think we all did. We probably just have like the summer. I'm getting ready for my. I don't have spring break. My parents do next week, and so my mind's already over there.
Mm-hmm. I apologize. I was able to go through the textbook pretty briefly. I wasn't able to get into too much depth.
Yeah, I mostly just watch the videos and breathe over the textbook, so it's cool.
Okay, which of the following summarizes the conclusion of this test? There is sufficient evidence to conclude that water quality in areas.
I agree with that.
Yeah.
Has decreased.
All right, I'm going to submit it and let you know what I get. Ooh, I got 100.
Do you mind if you just scroll through your answers real quick? The last one, D.
Yeah, what ones do you need? I'll do that for you.
Let's start from the bottom.
All right, bottom, okay. So my bottom answer is D. My 17 is reject. 16 is 0.011. 15 is negative 2.282.
Okay.
Okay, sorry to interrupt, but I'm going to go to work. I'll talk to you guys next week.
All right, yeah. Just make sure you get that turned in, and we're good.
I'll do that.
All right, thanks. Thanks for being here, Davis. See you later.
Thank you.